Hi everyone, I'm Sylvain Romain from Altix. I'm very glad to be today at Keysight Technology with my friends Todd Shaver, who is a manufacturing engineer. Todd is going to tell us a little bit more about Keysight and his experience on the Afosa. So back to 2013, Keysight decided to purchase one of our products, which is the Afosa with a 5 kilowatt lamp. Can we know a little bit more what was the motivation back then to purchase the Afosa, to acquire the Afosa?
Right. We were using an old OptiBeam exposer at that time, and this was before I was here. But I've had a chance to really talk with the people who were around at that time and get a sense for what we were dealing with. The OptiBeam was a capable machine, but it required manual alignment. And of course, what that means is we have a top and a bottom artwork, and under a microscope, by hand, we have to align the top and the bottom and then tape it with the correct number of spacers. And then we have to move that over to the exposer and then put the panels in and out and check that alignment every so often. But also, the panels that were going to that artwork were damaging the artwork because the top and bottom were taped together. So the issues we were having is that we were taking an awful long time for each job to align and to check our alignment. We had to have not just one copy of our photo tool, but multiple copies of our photo tools to allow for doing a job continuously without realigning. We would just have separate copies kind of pre-aligned. So we were spending a lot of time aligning, a lot of time maintaining artwork. And then the other thing that was making it a very high-risk instrument for us was the fact that it was unsupported. It was an older machine, and when we had issues with the machine, we had no support from the manufacturer. And that had the potential to really interrupt our supply lines and gave us a high risk for assurance of supply. So at that time, we were looking to decrease our risk, but also increase our capabilities. And for that, we looked at the Afosa.
So what was the benefits of the Afosa? What did you see on the Afosa that could resolve a lot of problems?
The Afosa provided us some really good stuff. For instance, with its automatic alignment, which I'll keep talking about because that's a primary benefit of the Afosa, one of the things it allowed us to do was to quantify our alignment of our top and bottom artwork when we're exposing. When done by hand, sure, it may have been aligned well. We may have even been able to align perfectly. I don't know. But it wasn't tracked, it wasn't measured, and it's up to one operator. So it depends on the person's skill and how close they want to get it. You have operator variability there. So apart from faster alignment is measurable and quantifiable alignment. The other thing that we really needed from the Afosa and from Altix actually, when we were looking for this machine, is Altix was the only company that was able to provide us 2 trays. And a dual tray system is not unusual, but Altix was able to custom build it to allow us a mylar sheet on the top one instead of 2 glass panels. And that allowed us to use one of our existing rigid photo tools that had tooling pins that couldn't be used with the glass panels. So not only do we get backwards compatibility with our old manual alignment artwork, but also we retain the capability for our legacy parts that require this rigid photo tooling that we couldn't use in the glass panels.
You're pushing the registration, I believe?
We're pushing the registration.
And the fact that it needs to be repetitive?
Yeah, so that, as I mentioned before, the size of our features is not what we're pushing the limit on. It's the repeatability of those features.
So I believe this is the one you like the most in the Afosa, is the capability to do repetitive alignment with it. Can you tell a little bit more about that? Yeah.
So with the Afosa, not only does it give us that value, it says here's what your alignment was. But what we see is panel-to-panel alignment is going to be within a few microns of each other. So that first alignment can be anywhere in the specs, I think, state plus or minus 10 or 15 microns. But once that job is locked in, panel to panel is going to be within a few microns. And it gives us incredible repeatability. That allows us in these parts where we're holding these really, really tight tolerances to be able to maintain that throughout the job. And that's really what enables and makes possible this class of really tight tolerance parts that we produce.
Let's talk about productivity. So before you have a manual machine and with the automatic registration, can you tell us more how much time you save and how beneficial was it?
We decreased our time spent on alignment by at least 1 hour per job, which is huge. I mean, when you only have an 8-hour shift, and so we might have been able to do 4 jobs in a day, and now we can do 8 jobs in a day. Again, we're working with small batch sizes, so when I say 4 jobs or 8 jobs, that doesn't necessarily mean something to other people. But again, for us, it's huge. So 4 jobs a day is like 4 hours a day. It's like half our time that we get now to either work on something else or to do more work.
In pushing your capability forward, do you see yourself looking for direct imaging? Do you see this technology being a kind of opportunity in the future?
One of those things I see with direct imaging is, so we're certified, we have an AS9100 certification, which is a military spec. One of the things that I would like to see is increased traceability on our parts. When we have to mark parts, we have ways that do it involving scribes and etching by hand into panels. But with direct imaging, one of the cool things I see is serialization of parts, which we can't currently do at the expose step. The other is this decreased reliance on a huge inventory of photo tooling. So that means quicker turnaround, that means lower cost, that means increased flexibility. And there are some areas that I see improvement for when we do secondary alignment, and that means our parts are going through, it's kind of like an outer layer process, but we go back through and we put in another photo mask to apply selective plating, gold plating. That can be a challenge because that second application of photoresist distorts the sheets in a way that our hard photo tooling can't account for. But I have a thought that the direct imaging can, and companies like Altix are able to map the distortion of the sheet and respond to that. I see that as alleviating some of our problems there. There's issues that we encounter that everyone who's using hard photo tooling encounters with pieces of resist sticking to the artwork and causing repeat defects. That's something we would hope to alleviate.
I would like to thank you, Todd,
for the time
you spent here and for preparing this interview.